Okay, so this is sketching quadratic functions, which we've kind of done before. It's just they're not in standard form. We kind of started with standard form, so this is really just the process of showing you how to take a quadratic function and put it in standard form. Some of them are pretty close to being in standard form already, but some take a little more time. So just to review standard form, let's say f of x is equal to plus or minus. So there's an a. I guess put an a in the front. A is positive, it goes one direction. A is negative, it goes the other way. So it's a times x minus h squared plus k. So this shouldn't be any surprise. So we just have to take these and convert them into that form. And once we do that, then we'll have an idea of what to do. Now we are going to have some stretching, but not significant. Okay, so let's start with problem number 1. So you can see this is pretty close to standard form. I'm just going to change the order of the terms. So it's going to be negative x squared plus 25. So you see that we have no x-axis shift. It's not written explicitly as x minus 0. You don't really need to put that in there. So if it's by itself, we know there's no x direction shift. We do have this negative sign out front, which means that it's a y-axis, an x-axis reflection. So what we're going to do is we're going to put it in standard form, and then we're going to define the vertex, which is h comma k. And we know that this is h and this is k. So our vertex is going to be at 0 comma 25. We also know that it's upside down because of this negative sign. One thing we'll have to do is we may have to change the scale of the graph to fit in the function. So you basically want to scale it so you can see the most detail of this function. So obviously, if the vertex is going to be at 0, 25, it means that we're going to have to go up at least to 25 here. And since I'm showing the entire graph, we're going to have to go to the same number in this direction. So you have to make it so that well, you don't have to, but it helps if these are multiples. These increments are multiples of some integer. Now, if I made them integer, if I did it into multiples of 5, then I would have 5 times 10, which is 50. So I wouldn't be using as much of the graph as I'd like to. So what I'm going to do is I'm going to put a mark every other grid line, and I'm going to say this is 5, 10, 15, 20, 25. Now, if this were a plus, then that wouldn't be very useful because it would be going up, but I know it's going to be going down. So I can plot my vertex. And the other things that we can do here is, because it's going to be going downward, I'm going to have some x-intercepts. So it might be worth figuring out what the x-intercepts are. So we've found the vertex, and now we're going to set the function equal to 0. Just a second, I need to turn this thing off. Even though it says it's not there, it is. It's annoying me. So you may not hear it, but I do. So we set the function equal to 0, and then we figure out the values of x where this function equals 0. So it's just a matter of factoring. So you'd have 5 minus x and 5 plus x. It's a little bit different than the normal way we're thinking about it, because I've got this number first and x squared second. But the same kind of philosophy applies. So I know two numbers together that equal 25. Well, there's only three integers, 1, 5, and 25. And this is x squared, so I know each one of those has to be x. And there's no middle term, so there's going to be a plus and a minus part with the same number. So if you set 5 minus x equal to 0, you'll get x is equal to negative x is equal to negative 5, or x is equal to 5. So that's one of the zeros. And you get 5 plus x equals 0, or x equals negative 5. So these are going to be the x-intercepts. And again, I may use a different scale in the x direction. It's x direction, y direction. So we'll use from negative 10 to positive 10. We'll go down here to negative 25. It has to be symmetric in this direction. So each unit will be 1. Each grid line will be 1 unit. So we'll go, this will be negative 5, and this will be 5. This will be 10. So I can plot the x-intercepts. Now, because I have, x equal to, it's x squared, you should be able to go, well, you can't go over 1 and down 1 because of the scaling. So what I would do in this case, I just would draw a rough parabola based on the vertex and the two x-intercepts. The y-intercept is also the vertex. So you draw a pretty good curve with just 3 points, knowing the general shape of a quadratic function and the x-intercepts. So that's what we're going to do with that one. Okay. The next one is actually already in standard form. And notice it did ask specifically for the vertex and x-intercept. So even though I didn't read that part, it's kind of ingrained in me. Okay, so the vertex. Well, this is in standard form. X minus h squared plus k. So h is equal to 6. K is equal to 3. So the coordinates of the vertex are 6, 3. Now, as far as the x-intercepts are concerned, you just set y equal to 0. Now, if you subtract 3 from both sides, first step, you'll notice that there is, if you tried to do the next step, which would be taking the square root, you'd have a problem. Because when you take the square root of a negative number, you don't get a real number. So what that tells you is there are no x-intercepts. So in this case, we have a parabola that's pointing upward, and the vertex is at 6, 3, which is about there, and it's going to go that way. So that kind of shows graphically why this thing is not going to work in that direction. So we need something other than the vertex to help us out. So in this case, I would probably make my scale so that I can do the over 1 up 1 thing that we did in chapter 1. So what I would do is I'd go over 6 up 3. There's my vertex. And I'm going to use a scale that's symmetric here, and it's just 1 unit on the grid is 1 unit. So I would go over 1 up 1, over 1 up 1, over 2 up 4, 1, 2, 3, 4, over 2 up 4. There we go. And now I could just kind of sketch it in there. And you can see why we ended up with no x-intercepts. If this were negative 3, then, or if this were a negative sign in front here, then I would be able to get a number. I get 2 x-intercepts. So with quadratic equations, you either get 0 x-intercepts or 2 x-intercepts. Okay, the next one is not in standard form, so we're going to need to do that. So the question is, how do we come up with the standard form? So the key thing, this is where completing the square comes into play. So we would take x plus 3x and put a quarter over here by itself. We need to leave a little space, so I want to move everything over a little bit to the left. So you take 3, coefficient, divide by 2, squared. So you get 9/4. 3 squared is 9, 2 squared is 4. You'd add 9/4, you'd subtract 9/4 so that we don't make any change in the value of the function. The argument in here is what is going to allow us to make the complete square. So it's going to be plus 3/2 quantity squared. So this can be rewritten as that. And you can see it works out because x times x is x squared. X times 3/2 is 3/2 x, but that happens twice. So you add those two together, you get 3x. And then 3/2 times 3/2 gives you 9/4. Now here we have 1/4 minus 9/4, which is going to be negative 8/4. So we get x plus 3/2 squared minus 2. Simplify that fraction. So now at this point we can do vertex. Vertex is going to be, well, it's x minus h squared plus k. So in this case that is going to be x minus a negative 3/2 squared minus 2. So I've got x minus h, so h is equal to negative 3/2 and k is equal to negative 2. Now just kind of in a general, what this thing going to look like, if you go negative 3/2, negative 2, you're going to end up here. It's a plus sign out in front, so it's going to go up. So we know we're going to have two x-intercepts and a y-intercept. So that means that's what we want to do. So anyway, the vertex is negative 3/2 x, negative 2y. If we set the function equal to 0, so we're going to have x. I'm going to just do it in this original form. So we're going to solve for x. So we add 2 to both sides. Take the square root, so you're going to get this plus or minus the square root of 2 is equal to x plus 3/2. So if you solve for x, you'll get negative 3/2 plus or minus the square root of 2. So what I've done is I've moved this to the other side. It becomes negative. And so at this point, we really need to come up with some decimal answer. So we've got negative 3/2 is in a decimal form, negative 1.5 plus or minus the square root of 2, which is 1.414. So if we do the positive part, positive square root, or positive term, we'll have negative 1.5 plus 1.414, which is negative 0.8086. So that's 1, 0, or 1 x-intercept. And we get x when we use the negative, so it'll be negative 1.5 minus 1.414, which is negative 2.914. Obviously, we're not going to plot them that close. This is approximately equal to negative 0.1, and this is approximately equal to negative 2.9. Okay, so now let's draw the graph. So we're going to get our graph paper out. And we'll just go ahead and go from negative 10 to positive 10. So the vertex is negative 1.5, negative 2, so that puts you right there. The x-intercepts are negative 2.9, 1, 2, 2.9, so that's about right there, and approximately negative 0.1. And your x-intercepts are always symmetric around the vertex, because if you look at it, this is the coordinate of the x-coordinate of the vertex, and then you add and subtract the same amount. So you have those 3 points. You'll also notice there's a y-intercept, and it's going to be about right there. So let's just look at what the y-intercept is. There it is. So it's a quarter, because if you set x equal to 0, you get a quarter. So that would give us one more point. It's actually about right there. So it didn't help you out a whole heck of a lot. But we've got the key things here. We've got the vertex. We've got the x-intercepts. It's pointing upward because the coefficient in front of x squared is positive. So that's all we have to do with that. Okay, we're on problem number 4 now. So we go through the same procedure. We're going to put this in standard form. Now the difference is how you deal with these first 2 terms. So what we're going to do is we're going to factor out a 2, because completing the square is something that you want to do when you have just x squared as the first term. So we'll do what's in the parentheses, and then we'll take care of it from that point. So you get negative 1/2 squared, which is positive 1/4. So you square 1, which is 1, you square 2, which is 4, and you square negative 1, which is positive 1. So we're going to add a quarter, and we're going to subtract, well, yeah, almost did it here. So we add a quarter inside the parentheses, but we're really adding 2 times a quarter, which is 1/2. So we're going to subtract 1/2 to balance that out. The key thing is if we simplify this, we should get back to where we started. It's just we have to get in standard form. So the complete square that results from these 3 terms is x minus this number. So it's going to be, so is it x minus 1/2 or plus 1/2? It must be x, so it's x plus whatever this number is. Okay, so in our case it's negative 1/2. So we're adding negative 1/2, and you square that. And you can see if I square this, I'll have, so what I'm doing, just to double check that I did this right, I've got x minus 1/2 times x minus 1/2. So when you use FOIL, first is x times x, which is x squared. You get minus 1/2 x from here, and you get minus 1/2 x from there outside, and then you get negative 1/2 times negative 1/2, which is positive 1/4. And so negative 1/2 plus negative 1/2 is negative 1. So I've done something wrong here. What did I do? Oh, okay. I'm glad I checked that, because I made a mistake. So how did I know? Because it didn't check. And then what I'm really doing here is I'm taking negative 1/2 and divide by 2. So since that was already 1/2, I kind of forgot that I had to divide it by 1/2. So you take this number, divide it by 2. That's the same as negative 1/4. So negative 1/2 divided by 2 is negative 1/4. You square that, you get positive 1/16. Okay, so let's fix that. So it's going to be plus 1/16. So we've got, if we add a 16th and multiply it by 2, we're going to add an 8th, 2/16, which becomes an 8th, and we have to subtract it because we added it over here. Okay, now if I checked it again, what I'd have is the complete square would be 2 times x minus 1/4 squared. And here I've got plus 1 minus 1/8. So we get 2 times x minus 1/4 squared plus 7/8. So 1 is 8/8 minus 1/8. 8 minus 1 is 7. And anyway, if I multiplied this out, since I made a mistake last time, let's prove that I know what I'm doing. So you've got x times x, which is x squared. You've got x times negative 1/4 and x times negative 1/4, and you get negative 1/4 times negative 1/4. So these two combine into 1/2. 1/4 plus 1/4 is 1/2. So that does work out right there. So this is the standard form. So the vertex is going to be at 1/4 and 7/8. And because both those are positive, it's going to be above, it's going to be right in the corner here, and then it's going to be positive, so it's going to be pointing up this direction. So they're not going to be any x-intercepts. There would be a y-intercept, which would be y equals 1, because if we stick 0 in for these two, we'll get 1. And as far as drawing it, because of this factor of 2, what will happen is we'll start at this vertex, and then we'll go over 1, up 2, instead of over 1, up 1. So that's kind of how we draw this thing. So let's add a page. Get some graph paper. And the question is, how do we draw this? Because if I do, if I just do the normal scale, which I'll do first, and see if I want to do something different. So the vertex is at 1/4, which is right here, and 7/8, which is going to be right there. You see the y-intercept is right there, which makes sense. So what you do is you go over 1 and up 2. You go over 1 and up 2. Then you go over 2, up 4. So that's, you go up 4, you go up 8. So you go over, so you're doubling what you normally do. You go over 1, up 2 instead of over 1, up 1. So you go over 2, up 8. Just going to put you right up here. And then symmetry puts you right there. And so there's your graph, approximate graph. And what I'm going to do is I'm going to just show you how you can prove that we're doing things correctly by taking this graph paper. So what I'm going to do is I'm going to shrink it up a little bit so I can keep it on this one side. Okay, so the first thing I'm going to do is I'm going to plot the original function, which is 2x squared minus x plus 1. And then I'm going to do the one in standard form because they should be the same. So I'm going to take 2 times x minus 1/4 quantity squared plus 7/8. I hope this is right because I don't want to have to redo this whole thing. And what I should see is one graph, and you can see that I do. See, there's two curves. There's the red curve and the blue curve, but the blue curve shows up because it covers up the red curve. And you can see the vertex here is at, if I zoom in on the vertex, it's x 0.25, y 0.875. So that's 1/4, 7/8. You see I have a y-intercept of 1. So that looks pretty good. It kind of looks like my graph, doesn't it? Okay, so I think that's the last one of the initial group. Okay, so the next one is similar. It says use a graphing utility to graph the quadratic function. Identify the vertex and x-intercepts. Check your results algebraically by writing in standard form. So it's really just what I did, except doing it the opposite way, like I just did. I plotted it. So what we'll do is let's do it in the order they say, and then we'll do it in the right order, and then we'll check things out. So I'm going to plot this graph, which is going to be negative x squared plus x minus 30. Now because of this negative 30, it's going to be way off the chart. So you can see it. And the negative means it's going to be pointing downward. So I'm just going to zoom out so you can see here's the vertex. Looks like the vertex is at y equals 30 and x equals something, negative something, like a half. You've got x-intercepts at, looks like about negative 6 and about positive 5 approximately. I could zoom in. So let's try it. So we got a vertex. We'll come back to this. I'm not going to write them down yet. We're going to do this analytically now. Okay, so we've got f of x equals negative. What I'm going to do, I'm going to take this last term out and put it by itself. So you're going to have negative the quantity x squared plus x, and then this negative 30, negative and negative 30, I'm going to put it here as plus 30. And you see that's why we have the vertex is close to 30, almost 30. It's not exactly 30 in the y direction. So this has a coefficient of 1. So to complete the square, you have 1 divided by 2. Take this, divide by 2, you square it. You'll get a quarter. Half squared is a quarter, so we add a quarter. But we're really subtracting a quarter because we got the negative sign. So to balance that, I have to actually add a quarter. So this plus becomes minus. And then this thing can be rewritten as a complete square, which is going to be x plus a half quantity squared plus 30 a quarter, or 30.25. So the vertex is at x equals negative 1/2 from here, so it's a negative and negative 1/2, and then you have the y value. So those match up pretty close, except we didn't zoom in, so we didn't know if it was not exactly 30. So that's the vertex, and then the x-intercepts. What we do is we take the function set equal to 0. So you've got, if you multiply everything by negative 1, you get rid of the negative sign. Everything else stays the same. Then you would factor this. So you have two numbers multiplied together give you 30. Difference is equal to 1. Well, that's 5 and 6. It has to be positive 6 and negative 5 because I need 6 minus 5 to give me a positive x. So you can see that the x-intercepts work out perfectly here. So x plus 6 has to equal 0. X equals negative 6. That's negative 6 comma 0 coordinates, and you have x minus 5 is equal to 0. X is equal to 5. The x-intercept is 5 comma 0. So now we're going to bring the graph back up, and I'll squeeze it over there. So if I zoom in on this, you can see it is exactly 6. It goes right through there. And then you've got this one over on the other side, which goes exactly through 5. That's the other x-intercept. And then you've got this vertex. So if I zoom in on that, you can see the peak is about right here, which says negative 0.5 approximately and 30.25, which are the coordinates. The exact coordinates are this. So that worked out pretty good. Okay. Next thing we're going to do is this one. X squared plus 10x plus 14. x squared plus 10x plus 14. And let's go back to standard. I'm going to zoom out. So I'm just going to zoom out in general, and then if we want to, we can shift this thing around. So if I zoom a little bit in the x direction, and then move it to the right, to the left, sorry, and zoom in, move a little bit to the right again. Okay, so that looks good. So you can see the vertex is about -5, -11. And the x-intercept here is around -1 2/3 and -8 1/3. And we have a y-intercept of, it's like about 14. Should be 14 based on that. Okay, so let's and we did have x-intercepts. Yep. Did I plot that thing right? Just x squared plus 10x plus 14. Okay, everything looks good. So again, we're going to put this in standard form. So we'll take the original expression, move the 14 over here, take 10, divide by 2, which is 5. 5 squared equals 25. So we add 25, and because there's no negative multiplied by it, we really are adding 25, and we'll subtract 25. So these three terms become a complete square. We use this number here, 5, square it, and you can see that if you multiply it out, we'll get to that. And we have 14 minus 25, which is -11. So that's in standard form. So our vertex, remember we have x minus h here, squared plus k. So really we have x minus a minus 5 plus or minus 11. So h equals -5, k equals -11. So the vertex is at x equals -5, k equals -11. As far as the x-intercepts, we set the function x squared plus 10x plus 25 equal to 0. But, what two numbers multiplied together equal 25 and add together 10? Well, actually, that turns out pretty easy. Does that seem, is that right? Oh, it's because yeah, that's wrong. Wrote the equation down wrong. Like, that doesn't make any sense. Okay, two numbers multiplied together to give 14 that out of 10. Well, 7 times 2 is 14, but 7 plus 2 is 9. 14 times 1 is 14, but 14 plus 1 is 15. So it's not going to be an integer. So we could use the quadratic formula, or we could really start with the standard form and solve for x. So what we do is we take the equation in standard form, and so we're going to add 11 to both sides, like that. Take the square root, so we'll get plus or minus the square root of 11 is equal to x plus 5. Or if we solve for x, x equals -5 plus or minus the square root of 11. And if we find out what the decimal equivalent of the square root of 11 is. So let's see here. Square root of 11 is 3.32. So the two numbers we'll get, if we subtract it, we'll get 8.32. 5 plus 3 is 8. It's going to be negative, and the second one is negative 5 plus 3.2. So it's going to be negative 1.683. Okay, so let's pull my graph out that we just did. I've already graphed that. Let's pull that over here. So you can see the vertex. If we go back here, it's at negative 5x, negative 11y. So that's good. Okay. I'm going to zoom out again here. The x-intercepts, let's just zoom in on that one. Negative 1.687. There you go. That's that one. And the other one is this one, so we'll just zoom in on it and put the cursor, and it says negative 8.316, negative 8.32. Okay, so it looks good. On to the next one. So this is the last one in this group, I think. Let's see what's next. Yep, okay. So this one's a little more tricky, but same basic idea. So you got f of x is equal to negative 4x squared plus 24x minus 41. So I guess we're supposed to graph this first. So we've got negative 4x squared plus 24x minus 41. Graph this thing out. Okay, we're going to have to zoom out to see where the heck it goes. So you can see there are no x-intercepts. There is a y-intercept if we go out far enough here. It's like negative 40-ish. Actually, it's negative 41. Okay, so there are no x-intercepts. So let's click on that. And we'll show you how you can figure that out without even graphing it. Once you can see I have negative here, so it's going to be pointing down like that. So if the vertex is below the x-axis, then there are no x-intercepts. If the vertex were above the x-axis, then you would have x-intercepts. So what we have to do is, once we find the vertex and we know which way this thing's pointing, we'll be able to show that we know there's no x-intercept, so we don't have to even try to figure out what it is. Okay, so what we're going to do is take these two terms, like we normally do. We're going to factor out a negative 4 of both terms. So when you factor out negative 4, you're just left with x squared. Here, when you factor out negative 4, you're basically saying let's divide by negative 4, which 24 divided by negative 4 is negative 6. So that's what you're left with. And then we have this negative 41 that's outside the parentheses. So we use completing the square inside the parentheses. So you get negative 6 divided by 2 squared, which is negative 3 squared, which is positive 9. So we're add positive 9. But we're not just adding 9. We're adding 9 in the parentheses, but it's multiplied by negative 4. So we're really subtracting 36, so we have to add 36 at the end here. Okay. Then we take the term in the parentheses and write that as a complete square, which is going to be x minus 3, quantity squared. And then we have negative 41 plus 36, which is negative 5. Okay, so that's standard form. So you've got the vertex has the coordinates positive 3, positive 3, comma. So it's x minus h, so h is 3. So that's plus 3 minus 5. No. Oh, so how do we know this is no x-intercepts? Well, this is in the below the x-axis because you go over 3, down 5, and it's going to be downward like that. So there's no way for x-intercepts. So now we can compare that with our graph. So you see, if we zoom in on the vertex, it's right here, which is x equals positive 3, y equals negative 5, and has a y-intercept of negative 41. Again, I'm going to zoom out till I get it in the screen, and then I'm going to do something here. I'm trying to zoom out so I get a little more detail. There we go. So we'd have this point and that point that agree. So excellent. And this is the last bunch, or there's some more after this. Okay, so we got this, and then we got 2 word problems. So now it says find the quadratic function that has the indicated vertex and whose graph passes through the given point. So what you do here is you write the function in standard form, but you put an a out in front of this, and then you have x minus h squared plus k. Well, we know what h and k are. So for problem number 8, h is negative 2, and k is plus 5. So if you plug those in, you get f of x equals a times x minus h, which is negative 2, square that, and add k, which is plus 5. So we need to figure out what a is. Well, f of x is equal to 5, and x is equal to negative 2. So these two things are defined by the point, which I wrote that down wrong. That's the vertex. So that's not going to help us out any. Okay, so we use this point. So x is 0, f of x is 9. So you plug that in. Before we do that, let's get rid of this double negative. So x plus 2 squared plus 5. Okay, so now we're going to plug in 0 for x and 9 for f of x. So you get 9 is equal to a times 0 plus 2 squared plus 5. Now we're just going to do the algebra. So you got 9 is equal to a times 0 plus 2, which is 2. 2 squared is 4 times 4 plus 5. Subtract 5 from both sides. You'll get 4. 9 minus 5 is 4. 5 minus 5 is 0. And you get a times 4, which is 4a. Divide both sides by 4. You'll get a is equal to 1. So now we can go back up here and write in the function. So the actual function is 1 times x plus 2 squared plus 5. And of course you don't need that 1, so we would say f of x equals x squared plus 2 squared plus 5. And if I plot that function, so I have it in standard form, which will be x plus 2 squared plus 5. I'm going to graph this thing, and you'll see at x equals 0 that the function is equal to 9. It's right there. Okay, so the rest of them are the same. Same kind of process. So number 9, the function is going to be a times x minus h squared plus k. We want to figure out what a is given this information. So the vertex, using the vertex as 2, 3, we can write this as f of x equals a times x minus h, which is 2, quantity squared, plus k, which is 3. Then we use this f of 0 is 2. So that means f of x equals 2, x equals 0. Plug those in, you get 2 is equal to a times 0 minus 2 squared plus 3. 2 is equal to, well, here we have negative 2 squared, which is positive 4, so I'll get 4a plus 3. Subtract 3 from both sides, you get negative 1 is equal to 4a, or a is equal to negative 1/4. So divide both sides by 4. So that's your a. So now again we can go up here and substitute those in. So the final answer is a is equal to negative 1/4 x minus 2 squared plus 3. So we're going to see if that's true or not. So we'll go to the graphing program. We'll do negative 1/4 times x minus 2 squared plus 3. Graph that thing. Go to standard zoom. So there it is. It's negative, so it's pointing down. The vertex is at 2, 3, and at x equals 0, y equals 2. X equals 0, y equals 2. So that is confirmed. And then the last one in this group, which is 10. So we're going to start off with f of x equals a times x minus h squared plus k. Okay, so h is equal to negative 5, and k is equal to 12. And so let's substitute those in. F of x equals a times x minus a negative 5. Did I do something wrong in that last problem? No, I did that right. Yeah, okay. And this is where I'm wrong. I knew I was doing something wrong. So h is positive 5. I don't know why I did that. Because it's x minus h is from here, 5. So it's positive 5. So you have x minus 5h squared plus k. Okay, in this case, x equals 7, f of x equals 15. So we get 15 is equal to a times x minus h squared plus 7. So for x I put in 7. So the difference is, when I go here I got to put in the value of x, which is 7. Okay, so we get 15 is equal to a times, 7 minus 5 is 2. 2 squared is 4 plus 12. Subtract 12 from both sides, you'll get 3 is equal to 4a. So if you subtract 12 from here, you get 0. 12 from here, you get 3. And so a is going to be equal to 3/4. So we go up here and substitute in. So you get 3/4 x minus 5 quantity squared plus 12. And let's plot that thing. So 3/4 times x minus 5 squared plus 12. And we got to zoom out a little bit. So there it is. So what this is saying is that the vertex is at 5, 12, and it said at x equals 7, So let me just make this a little bigger. X equals 7. Y should equal 15, which it does. So there you go. And because 7 is 2 more than 5, if you go this way, this should also be the same, 15, from symmetry. Okay, and the final two problems are word problems. So the first one is the number of horsepower Y required to overcome wind drag on an automobile is approximated by this curve, this function, y equals 0.002s squared plus 0.005s minus 0.029, and this equation is good from 0 to 100, where s is the speed of the car. So what happens is it's a quadratic function, so it's going to increase, but it increases more as you get higher speed. It says use a graphing utility to graph the function and graphically estimate the maximum speed of the horsepower of the car if the power required to overcome wind drag is not to exceed 10 horsepower. Verify your answer analytically. Okay, so let's get our graphing program here. So let's move that over to this side. So all we have to do is put it in, and we have to resize it so that we can see what the heck's going on. So you've got 0.002 x squared, so I'm using x because that's what the program requires, plus 0.005 x minus 0.029. Now, you might be saying, well, at s equals 0, I get negative 0.029, which doesn't make any sense. And it's just because this is a curve fit to some data, so it's not going to be exactly right. Okay, so we graph it, and you can see that I'm going to have to zoom in the y direction, or the other way. Zoom in the y direction. And it says it's good between 0 and 100, so I really need to zoom out in the y direction a lot. So I should have waited. Let me get all the way. So there's 100. So I'm going to zoom in the x direction to spread this thing out a little bit. And then I need to zoom out in the y direction so that, yeah, I keep going the wrong way. Okay, zoom out. Zoom out. So that has to be to 100 again. So there's the domain. And now I have to do it the other direction. So I'm going to zoom out like that. There we go. So you can see at 100 miles per hour, we get a horsepower of around 21. So it says graphically estimate the maximum speed of the car if the power required is not to exceed 10 horsepower. So here's 10 horsepower. So if we go over here to y equals 10, you can see the speed is about 69, 70 miles an hour. And so let's write that down. So we're going to say 70 miles per hour. The horsepower is 10 horsepower. What that means, if you have a 10 horsepower engine, you can't go any faster than 70 miles an hour. It's just going to run out of power. That's what limits speed of cars to some extent, is as you go to higher speeds, you get more wind drag, and the other factors slowing the car down, like tire deformation, friction in the engine. Those probably get small relative to the wind drag. So anyway, so now we're supposed to verify it. So what happens is we have the answer is y, which is 10. So we say 10 is equal to 0.002 s squared plus 0.005 s minus 0.029. So we're going to make this into a quadratic equation, but so the only thing that really happens is we're going to subtract 10 from both sides, so we get negative 10.029 here. And now we have to find the values where this function goes to 0, and that would be the corresponding speed that we looked up on the graph. So how do we do that? Well, one way would be to multiply this by a common factor just to make it a little easier to deal with as far as the calculations are concerned. And I'm just looking for my calculator, which I don't. Oh, here it is. So if I multiply by 500, let's just try that up. 0.002 times 500 is 1. Okay, so we're going to multiply everything by 500. And what that'll do is it'll make this s squared. And then if we take 0.005 times 500, we'll get 2.5 s. And then if we take 10.29 times 500, that'll be minus 5,014.5. So these functions have the same zeros, because if I factored out 0.002, I'd have this 0.002 times this. And so the reason I did that is because we're going to have to use the quadratic formula. So s is going to be equal to minus b plus minus the square root b squared minus 4ac over 2a. So in our case, a is equal to 1, b is equal to 2.5, c is equal to negative 5,014.5. So we get s is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. 2a, a is 1. So just divide by 2. So we'll get negative 2.5 plus or minus the square root of, so we get 2.5 squared inside the square root, minus 4 times 1 times negative 5,014.5. So that's the square root of 20,000. It's 64.25 divided by 2. So the square root of that is 0.5. So we get s is equal to negative 2.5 plus or minus. We're going to take the plus because we don't want to be going backwards. It doesn't really apply to negative speed anyway. So 141.65 minus 2.5 divided by 2 is 69.6. So that's pretty close, miles per hour. Close to what I got from the graph. So that's the analytical solution. One thing, notice here we chose our plus or minus so that the resultant s was in the domain. If you look back at the original equation, s had to be between positive or 0 to 100. The other solution would be a negative, which is not a practical solution. Okay, the next one, a study was done to compare the speed in miles per hour with the mileage of an automobile. The results are shown in the table. Use a graphing utility to create a scatter plot of the data. Use the regression feature of a graphing utility to find a quadratic model for the data. Use a graphing utility to graph the model in the same viewing window. Estimate the speed for which the miles per gallon is greatest. Okay, so here's our data. So we're going to use Excel to plot this. So I'll go through the whole process of doing Excel here, show you how it works. So we're just going to create a new spreadsheet. Need to create a table, and the table is going to consist of speed in one column and mileage in the other column. Okay, and the values are 15 to 75, so you type in 15, 25, so they go in increments of 5, so you can write the first two values, highlight those, and just drag it down far enough to get to 75, which I'm not exactly sure how far that is. So seems like I got to go a little further here. Okay, now you could just manually enter those numbers if you wanted to. Okay, next we're going to put the numbers in. So I'm going to try to get these so I can see them both at the same time, so I don't have to keep switching between the screens. So 22.3, 25.5, 27, 27.5, 29, 28.8, 30, 29.9, 30.2, 30.4, 28.8, 27.4, 25.3, 23.3. Okay, so those are the data points. And you can kind of look at it visually and see that the maximum is somewhere in this 45 to 55 mile an hour range. And it's not, no, this must be 25.5. So the way you do it is you highlight your data, you go to Insert, and over here Chart, we're going to choose this one, which is called a scatter plot. And we'll pick this one, which is just the data. Now I'm going to move this to another, what's called Move Chart. So you go up here to Move Chart, pick New Sheet. What that does is it just puts the graph on a separate page so you can look at it more easily. And then so that's the first part of the problem. Use the graphing utility to create a scatter plot. So that's what's called a scatter plot. Use the regression feature. So that is, go back here, regression, you click on data point, any data point, and they get all highlighted. Then you right click and do add trend line. And it says use a quadratic, so that's polynomial. And a quadratic is an order of 2. So you say that's good, and you come down here to display the equation on the chart. So we'll say that's done, so we'll close that thing up. And if you click on the data, you can then make these numbers bigger so I can actually see them. So we'll go to Home, and we'll go up here to Font. We'll pick something bigger. So there's the equation. So that's the regression. Now, what we're looking for is where does this regression peak? So let's see what's asking us again. Use the regression feature to find a quadratic model. Use the graphing utility of the model in the same viewing window. So what we're going to do is now is we're going to write down that equation. So we get y is equal to 0.00 negative 0.0082x squared plus 0.74661x plus 13.469. And we're going to use that equation to generate a third column. So this is, we'll say this is equation. And it's going to be equal to negative 0.0082 times x, which is the speed. So we click in cell A2, we square it. We add 0.7481 times x, which is cell A2. And we add 13.469. And the number we get should be close to being 22, which it is. Okay, so that's pretty close to that. And then to copy the formula, you just click on the cell, grab this corner, drag it down. That copies the equation, and you'll see that the numbers match up pretty closely.